Afternoon to all of you. In today's class, we will learn about the virtual LAN. In the first chapter, you have been introduced to the local area network and what is its significance and where it is used. I hope you all remember that. Now, today we'll see what is a virtual LAN. I hope you all know to create a local area network, you need few end devices and you need the switch, right? So to create a local area network, you'll have the layer 2 switch or layer 3 switch, and then you can connect the end devices to this switch. Now this forms a local area network. Now what is VLAN or virtual LAN is, you can divide this local area network into smaller sub networks logically. That means they all will be physically attached to the same switch, but then logically they can work like a separate LAN. Say for example, these two PCs can become one virtual LAN. These two PCs can become another VLAN, and this one PC can be part of another virtual LAN. The reason why we go for virtual LAN mainly is to reduce the broadcast traffic. Now, as you already know, in the local area network, suppose if this PC is sending a broadcast traffic, all the other PCs in the network will receive this traffic. Okay. So in this case, there are 4 more machines. All 4 of them will receive the broadcast traffic. Suppose if there are 400 machines in the same LAN, all the remaining 399 will receive if this PC is sending the broadcast traffic. So we want to minimize the broadcast traffic to based on the types of users who is present. Say for example, let's take this is the PCs that belongs to the student community. And let's take this is the faculty PCs. Okay, and let's take this is the admin VLAN. So if somebody from admin VLAN sends a broadcast traffic, it need not be received by any students or any faculty. So in that case, if you want to restrict them to within a VLAN, we go for this VLAN configuration. Okay. Now this is one case where we want to reduce the broadcast traffic. Sometimes you want to apply certain security policies. Okay, so if you want to apply any security policies specifically for student community, different ACL policies, faculty, different policy, admin, and different privileges and different types of traffic is going to flow. So in that case, if you group all these machines based on to which group of people they belong, we can apply the policies easily, okay, without affecting the others. Now, say for example, let's take this is the case of a CSE building. Now, the same kind of students, faculty, and admins are there in other blocks also. Say for example, we have the AI block. So in that also there will be many machines which belongs to students, which belongs to faculty, okay, and which belongs to the administrators. Now all this would be connected to a switch which is present in the AI block, right? But you want to provide the same features for the student community and for all the faculty the same kind of privileges. So in that case, we can extend this VLAN to the next building also, so which we call it as the extended VLAN. Okay, so you need not recable this 3 PCs of the students and connect it to this switch. This need not be done, but rather they can be physically attached to this same switch, but logically this student VLAN and the student VLAN of this AI block will be considered as a single VLAN. Okay, so no matter in which building they are present, all the students can be put in a same virtual LAN all the faculty machines can be put in another VLAN and so on. Okay. So what we are actually doing is a physical LAN can be grouped into subgroups based on the requirements. Got it? So now how do we configure this and what are the different types of VLANs are there? We will see them. Now, so here you can see an example of how in every floors there are all the three department machines are there. Say for example, here you have the IT department machines, you have the HR department machines, sales department machines. So all these, these two machines belong to IT, these two belongs to HR, and these all belongs to sales, and they all are attached to the same switch. Okay, but then in every floor such machines are there. Got it? But still, all these 6 machines will work like a VLAN, virtual LAN. Physically, they are attached to different switches, but logically, they work as if they belong to the same virtual LAN. Now, in VLAN, you have 2 types of configurations, which you should know. One is called as the intra VLAN, and the other one is called as the inter VLAN. Now, what do you mean by intra VLAN is when device belonging to, say, let's take this is VLAN 2 as mentioned here. Every VLAN is identified by a identifier, which we call it as the VLAN ID. Okay, so any device belonging to the same VLAN are communicating, then that is called as intra VLAN. So if these two PCs talk with each other, they send traffic, that is called as intra VLAN. But if a machine from one VLAN talks with another machine of a different VLAN, then that is called as inter VLAN. Okay, so if the machines of same VLANs are communicating, that is called as the intra VLAN. And if the machines of different VLANs are going to communicate, that is called as inter VLAN. Now you can see the different features that are offered by the VLAN. What are the characteristics? We can provide segmentation of various groups of devices on the same switch. So though all these are connected, all these machines are connected to the same switch, they work like they are attached to 3 different switches and they are working like a separate network. Okay, so we can manage large networks efficiently because we are able to restrict the broadcast traffic. So if one machine sends a broadcast traffic, only the machines inside this VLAN will receive, nobody else will receive it. Okay, and then so we are able to isolate all the other machines from receiving the traffic. And so we are able to reduce the size of the broadcast domain. Normally, to reduce the broadcast domain, we have to have a router because router doesn't forward broadcast traffic. Now, even without the router, we are able to restrict the traffic to a small, less number of devices by implementing the VLAN. And every VLAN will have a different network address. Say, for example, here you can see this is a class A address, but it's a subnetted address that you can know it by looking at the prefix. So 2.0 is one network, 3.0 is another network, 4.0 another network. Normally, when you configure, every PC is connected to this which belong to a same network, right? That's how you have learned in all the other configurations. Now here you can see that these 2 PCs are going to have 2.0 network. These 2 are going to have 3.0 network, and these 2 machines are going to have 4.0 network. Okay, so they'll have a unique range of IP addressing because all of them are now considered to be a separate network. Now, what are the benefits of having this VLAN? You can reduce the broadcast domain. You can provide more security. You can handle efficiently based on the device's requirements. Then you can reduce the cost because you need not purchase more switches. With the existing switch itself, you can accommodate a number of VLANs. You can improve the performance because we are reducing the broadcast traffic. Thereby, we are preserving the bandwidth, medium bandwidth, and similar groups. Suppose if you are applying any priorities or any QoS policies, we can apply them to the respective groups. Now, how do we configure this VLAN? So before we go for the configuration, we have to load certain types of VLANs. Okay, by default, all the devices are considered to be part of a default VLAN, which is called as VLAN 1. Say, for example, this configuration should be done on the switch. Okay, we have to apply the configurations on the switch, right? So if a switch has, let's take it has 24 ports, and all the ports FA0/0, FA0/1, they all will belong to the default VLAN, that is VLAN 1. Okay. Now there is another type of VLAN called as native VLAN. Now this is a special type of VLAN 1 where the physical ports are not existing, but imaginarily it is there, and it is needed for the trunk links. Okay, so I haven't explained what is trunk. A little later I'll explain. Okay, and then you have another type of VLAN which is called as the management VLAN. For example, if you are using the SSH for remote login, or you're configuring the telnet, okay, that means you're using the VTY for configuring the devices, we'll use the management VLAN. Okay, now this is one VLAN, VLAN 1, which cannot be deleted. It is existing. So for example, if you give in the switch the command show VLAN brief, okay, so you can use two commands. VLAN, show VLAN is a command. You can use show VLAN to see what are all VLANs are existing. And if you want to see only the important information, then you can use the command show VLAN brief. Okay. Now here you can see all the 24 ports. Okay, fast Ethernet 24 ports, 2 gigabit Ethernet ports, all are belonging to the VLAN 1 by default. Okay. And we have some more VLANs which are automatically created, which is used for the token ring and then FDD protocol, okay, which will not be using it. So how many bits are used for representing this VLAN ID is 12 bits, okay. So therefore you can create how many VLANs? 4096 VLANs, and all these are automatically created. The rest all can be created by the user. Okay, so VLAN 1 cannot be deleted. Now we can create any number of VLANs, and those VLANs can be used for sending the user traffic. Say for example, email, web traffic, any type of user data traffic can be sent with the user defined VLANs, or also it can be sent through VLAN 1. And this native VLAN, suppose if there are any untagged traffic, say for example, when we create VLAN, every traffic should carry the VLAN ID also. Okay, say for example, if we have a switch, and let's take, we say that this PC belongs to VLAN 100 and this PC belongs to VLAN 200. And if this PC is going to send a traffic to somebody, this packet should carry, okay, this packet which is going from this PC out of the switch should carry the VLAN ID, okay, which we call it as the VLAN tag. And in the native VLAN, so in the trunk links, now what is a trunk link is, say for example, I have a topology like this. Now this is actually a crossover cable. It should be a dotted line because two similar devices, when you connect, it is use the crossover cable. Okay, so it should be a dotted line. Now in this link, if you take, which VLAN's traffic is going to come? Only hundreds traffic. Okay, if you take this interface, only 200s traffic is going to flow. What about this link? Both 100 as well as 200s traffic should go. Yes or no? Now, if you take in this one, let's take this is VLAN 100 and this is VLAN 200. Then in this case, only 100s traffic will flow, here only 200. But what about this? Suppose if it's coming out, here both should flow, right? So if you want to allow more than one VLAN's traffic, then the ports of the switch have to be configured as the trunk port. Okay, it has to be configured as the trunk port. Now, if it is allowing only a specific VLAN's traffic, then that is called as the access mode. Okay, so there are two modes, access mode and trunk mode. So in trunk mode, multiple VLANs packets can travel. Whereas in access mode, only one specific VLAN which is configured, only their traffic will flow. Okay. So if there are any packets arriving without any tag, then they should be allowed. Okay. Say for example, if we say, if we write here 100 and 200, that means only the packets that carry the number 100 and 200 will be allowed on this trunk link. But if you want to allow even the packets which are not tagged, which originates from this VLAN 1, in that case, we have to create the VLAN, native VLAN. Okay. Now, for voice VLAN, separate VLAN is created because for voice traffic, we need better bandwidth. We have to ensure high QoS service. We have to avoid congestion. The delay should be less than 150 milliseconds. Therefore, the devices that belong, that's going to carry voice traffic should be always put in a separate VLAN, and we call that as the voice VLAN. Now, how many VLANs can be created in a switch? How many bits are used for creating the VLAN ID? 12 bits, right? So therefore, you can have 1 to 4096 VLANs, out of which that 6 VLANs are fixed, the rest all can be created. Okay, so we can create that many, around almost 4000 VLANs can be created. So in this link, in this diagram, you can see 3 VLANs are created. So all these are going to be access ports. This is going to be the trunk port. This is going to be trunk. This is going to be trunk. This is going to be trunk. And these all are going to be access ports. And to attach this tag, the protocol that is used is called as IEEE 802.1q. Okay, it is IEEE 802.1q protocol is used for adding this VLAN ID to the packets. So if a network without VLAN is sending a broadcast traffic, so if it is sending a, suppose if PC1 is sending a broadcast traffic, who all will receive? Which all machines will receive? All of them will receive. PC2 will receive, PC3 will receive, and this switch will forward the broadcast traffic. Then S1 will forward it to S3. S3 will send it to all of them. So all the machines will receive the broadcast traffic. Suppose if VLAN is created, and if this PC1 is going to send the traffic, who will receive the broadcast traffic? It is only this PC4 who will receive the broadcast. Nobody else will receive. The reason is this belongs to VLAN 20. This belongs to VLAN 20. So therefore, only this machine receives it. Now, this is the tag that is attached with the packet. So this is the, this happens in the layer 2, the data link layer. So you have the destination MAC address added, source MAC address added, the length of the frames then the actual data that has come from the network layer. This is for error checking, frame check, sequences added. So this is an additional bits which is added for the VLAN. And this tag has number 4 bytes totally. So in that 2 bytes is used for the type that, so this actually type represents the IEEE 802.1Q. Okay, so for that the hexadecimal represents 0x8100. Then you have 3 bits for specifying the user priority, and then CFID. This is a 4-bit value that is added for the token ring, and then the actual VLAN ID. So VLAN ID is 12 bits. Okay, so these are the information that gets added with the frames in the data link layer. Now, so this range, VLAN numbers, you can make a note of it. VLAN number 1 to 1005. Okay, this we call it as a normal range, and 1006 to 4095, they are called as extended ranges. They are normally used only by the service providers. Whereas for all the organizational networks, small to medium sized businesses, they make use of the ranges from VLAN 1 to 1005. And 1002 to 1005 are auto created, so we cannot delete it. And all the information about the VLANs are stored, the configuration. Normally, when we do the configuration, where does it get saved? Anybody knows where the, whatever configuration we do, where does it get saved? In which file does it get saved? It gets saved in the running configuration file, right? So where is this running configuration file? It is present in the NVRAM. So that's where it is saved. Now the configuration that we do for the VLAN gets in saved in a file called as vlan.dat. So it is a file which is present in the flash memory. Okay, so even if you erase this NVRAM by writing the command write erase, and when we reload it, this VLAN that is created will not get erased, or it will not be removed. So only if you delete this file vlan.dat file, we can remove the VLANs that are created. So all the files, all the configuration that we do for the VLAN creation gets saved in this file. So the configuration commands I'll directly show in the packet tracer. Now, one more thing which you have to know is there is another protocol provided by the Cisco, which is called as the dynamic trunking protocol, or DTP. Dynamic trunking protocol. Now, this is works only on Cisco devices. Now, what is the use of this protocol is it has the auto negotiation. Say, for example, in the earlier, default VLAN, we have 2 modes. We have the access mode, where we say that it can allow only a specific VLAN, and we can configure the trunk mode, where we say multiple VLANs traffic can go. Now, in this case, in the DTP, if one side, so if you have a link like this attached to a switch, if one side is configured as trunk, automatically the next side also will be taken as the trunk mode, provided this DTP protocol is configured. Okay, so now we have 2 more options for this. One is called as the dynamic auto. If this is configured, then if one side is trunk, the other side also will be trunk. So if the one side is access, the next side also will be access. Okay. The next type is dynamic desirable. So this is the next option which is available, dynamic desirable. Now, what do you mean by dynamic desirable is, suppose if one side is configured as dynamic desirable, then if the other side is configured as trunk, then this side also will automatically turn to trunk. Okay, so this, where the whichever side is configured as dynamic desirable, will seek, or it will find out what is the other side is configured, and based on that, automatically the configuration can be will get enabled. Okay, similarly, the dynamic auto also automatically, if one side is configured, with access, the next side will be access. Okay, so automatic configuration is there. So by default in the 2960 and 2950 switches, this DTP is enabled by default. So if we don't want to enable these two automatic, but we want to manually configure it, then we have to use the command no negotiate. Okay, so we have to configure the command switch port no negotiate to disable this auto configuration. Okay, and this works only on the Cisco switches. Okay, so this configurations also we will see. So now let me go to the Cisco packet tracer. Can you see the packet tracer? Is the packet tracer visible to all of you?
Yes, ma'am, it is visible.
Yes, okay. Okay, now let me quickly create two physical LANs. I'll use the 2960 switch. Now the left side PC, I'll just color it so that you'll not make mistakes. This I'm going to keep it belonging to the student VLAN, and the next PC I'll keep it as the faculty VLAN. Just have with two devices I'll show. You can experiment with more devices. Now, just table. Okay, now we'll use the address. So let me take the address as dot 8. Let me keep it as 8 so that I can finish the configuration quick. Then 20.20.20.0 network. And so all the yellow color machines belongs to 10.0 network, 10.10. It belongs to the same network, and green belongs to 20. Now let me assign the PC's address. The gateway I'm going to use 10.1. Okay, now I have assigned the IP addresses for all the 4 PCs. Now I'm going to create the VLANs. Okay, so before creating the VLANs, let me show you what VLANs are already existing. So we'll go to the switch, and the command to see the VLAN is show VLAN. So you can see the list of VLANs which are already present. We haven't created any. So you can see that all the ports, all the 24 ports are belonging to VLAN 1 and 2 gigabit Ethernet. All of them by default belongs to VLAN 1. And these are the VLANs which are automatically created, which we cannot delete. Now we are going to create a new VLAN. So the configuration is, you can make a note, configure terminal. Very simple. You just have to give VLAN and then the VLAN ID. So this ID number can range from 1 to 4096. Okay. Other than these numbers which are listed here. So now we'll create a VLAN and we can assign the name for the VLAN. So let me assign the name as student. Similarly, I'm going to create next VLAN, say VLAN 200, and I'm going to name it as faculty. So these are the steps for creating the VLAN. So now we'll check the VLAN, what our VLANs are created. So you can use show VLAN or you can use show VLAN brief also. If brief is there, all this information you will not see. Okay, so in short, you can see it. So 2 VLANs are created, 100 and 200, and it is active. So VLAN is created, but we haven't said these VLANs should be assigned to which ports. That is not yet done. Okay, so now we have to assign which port. So this port FA0/1 should route which VLAN's traffic, VLAN 100, and this one should allow VLAN 200. So now we'll assign the ports to these VLANs. So we'll choose the interface FA0/1, and then the command is switch port mode access. Now this is the 2 modes, either trunk mode or the access mode, and then we'll give access mode, and in the access mode we'll mention what type of VLAN should be allowed. VLAN 100 is allowed. Okay, so now you can see that the port has changed to orange. It will take little time to come up. Okay, so similarly we'll assign for the FA0/2, and we'll configure switch port mode access, and in the mode access we will allow VLAN 200. Okay, so that means only VLANs 200 traffic is allowed. Now if you want to the yellow color machine, no, this machine and this have to communicate, then that is called as intra VLAN. Okay, within the same VLAN we should be able to communicate, but if you have to communicate between these two, though they are sitting next to each other, they will not be able to communicate because this belongs to a different VLAN, this one belongs to different VLAN. So for which we need a router. So before we add a router, we'll just test the VLANs. Okay, so the same steps I'm going to do for the next switch also. So in both the switches, you have to configure the VLAN. Okay, now I have configured it. Now, if I ping from this PC 10.10.10.2 to 3, this machine, it has to flow through this switch, cross this crossover cable, then enter here. So therefore, this side, no? This side should allow both the VLANs, if at all it has to talk this side, okay? So this FA0/3 in both the switches should be configured as the trunk. So interface FA0/3 and configure at switch port mode trunk. And you can see that no, earlier it was green, now it has changed to orange. Switch port trunk allowed, which all VLANs should be allowed. So we want to allow VLAN 100 and 200. Okay, so now in the FA0/3, both the VLANs, that means only VLAN 100 and 200 will be allowed. Suppose if you want to allow only 100, then you need not give 200. Okay, so you can restrict which all VLAN should be allowed in each of the interfaces. Okay, so now I have given the configuration. So access side is completed, trunk is completed. So now we can ping and check whether you are able to ping within the same VLAN. Okay, it is successful. Okay, so now if we ping from green to green, it is successful. But if I ping from yellow to green, it will fail. The reason is this belongs to one VLAN, this belongs to another VLAN. So now if we have to make VLANs, machines belonging to different VLANs to communicate, we have to have a router. So now I'm going to add a router. So let me add a router here. Okay, now I have added. Now, how many gateways are there? As per this topology, how many gateways are there? Can you give in the chat box the answer? Totally, how many networks are there and how many gateways are there and what are their addresses? Students, can I get your response in the chat box? How many VLANs are there? 2, okay. What are the gateways? 2 gateways are there. What are the addresses? Can you tell me the addresses? Only 4 have responded. What about okay, 10.1 and 20.1. So 2 gateways are there, but you can see here only one physical cable is there. How will I configure these 2 addresses? I should have a cable, one more cable, right? So if I have one more cable, one cable I can use for 10.1 network, and this I can use for 20. Okay, so this is the legacy method of having separate physical interfaces for VLANs. Okay, for every VLAN you have a separate cable, but this is very costly. For every VLAN, if you have to have cables, and if there are 400 VLANs, can you connect 400 cables between the switch and router? It's difficult, no? It's not cost effective. So we go for the next method, which is called as a router on a stick. Router on a stick method, where with a single cable itself, we will be creating sub interfaces and we will assign the gateways. Okay, so now I'll show you the router on the stick method, where with a single cable, we will be able to provide multiple gateway addresses. So you can note down the configuration commands for the router. So enable config T So initially, we'll make the interface up by giving FA0/0 and we'll give no shutdown to make the physical interface up. Okay, so now it is changed to up. Now we'll create the sub interface. So how do we create the sub interface? So this is the name of the physical interface. To that, you have to add the VLAN number. Okay, so suffix dot 100. So now a sub interface is created and we have to add this to this interface, the VLAN ID. Okay, so the command is encapsulation dot 1Q. Okay, so as I already said, the protocol name is 802.1Q. So we'll enable that protocol here with the VLAN ID and then we'll assign the IP address. So 10.10.10.1 followed by its subnet mask. As usual, how you set the IP address. So similarly for the second VLAN also, we'll create the sub interface. We'll attach the VLAN ID to that. And then we'll assign the IP address. So what is going to be the address? 20.20.20.1. So this is the configuration. So now if you check the routing table, you can see that two networks are directly connected and it is attached to this sub interface, virtual interface, which is created FA0/100 and 0.200. So now we'll ping and check from yellow to green. Okay, one step I missed. This side also we have to configure it as the trunk mode. The reason is both VLANs have to travel here. So we'll configure that. Interface FA0/4, switch port, mode, trunk. Switch port, trunk, allowed 100, 200. Fast forward. Okay, now we'll ping and check. Yes, successful. So now we are able to communicate from any VLANs to any other VLAN. So this is how you configure the VLAN. Now, what are the different troubleshooting commands you should know? You have to use the command show VLAN brief, show VLAN summary. This is supported. Okay, so summary is not there, but it works in real devices. If you want to specifically see any VLANs information, then you can use the command show VLAN 200. Show interface. Okay, so this also doesn't work. Let me check trunk, whether we are able to check. Show interfaces trunk. This is one troubleshooting command where you can see whether the protocol 802.1Q is enabled and for which all interfaces it is enabled. 4 and 3. The trunk mode it is enabled. And then what VLANs are allowed, that also you can see here. And if you want to see the DTP protocol, because I chose the 2960 switch. So if you want to see the whether the dynamic trunking protocol is enabled or not. You can use the command show DTP, and you can see that two interfaces are using the DTP. And which interface is that? These two interfaces, FA0/4 and FA0/3. Okay, and we can see that the VLAN.dat file. Okay, so this is the file where the VLAN configurations are saved. So if we want to remove all the VLANs which we have done, then we have to use the command delete flash VLAN.dat. So it will ask, is this the file? Okay, and then if we say yes, it will remove it. So if we say no, it will say confirm. Again, I'm giving no. So therefore, the deletion is aborted. Okay. So if you press Y, it will delete the VLANs that we have created. Okay. So this is how you can delete the VLAN file and then create a new one if required. So I hope you have understood the configuration. If you have any doubts, you can ask. Any doubts? How many of you have understood? Can you respond in the chat box? Okay, then you have understood and there are no doubts. I think we can stop for today.
Hope ma'am has completed the class. Important announcement for the students. The module 2